Hello, this is another episode of describing my way through my hi-fi adventure. This time it will be 3 parts or 3 different topics that I would like to refer to. One is the tube amplifier and some updates that I've done on my Darling amp. Next one up will be what's going on my CD players. So there's a stack of 3 CD players which I currently own, and they undergone a couple of modifications that I would quickly describe. And then as the last part, I refer to some of the work which I've done on my speakers, and there's maybe just really one thing that you can see here. This is just the remainings of my old open baffle speaker, but right at the top you can see the Fostex FE126, which came right off my petit, and I will describe a little bit what are my plans with this tiny, small, little, wonderful speakers. So first up, back to the tube amplifier. And as you can see, and maybe you see or saw already some of my previous video, nothing really changed at the top surface. So all of the interesting bits which have changed are on the bottom side or on the rear, because the position that you see right now here, this vertical up position, is how I used to also operate my tube amplifier, and I once already described that this is linked to also the venting of the tubes, so that I've got some nice airflow which can just really pass through the tubes up and cool off the tubes. So they are all nice and cooled, and they don't really block each other, so they are already all offset versus each other slightly, so that none of them is in the wake of the other hot air. Now I try turning the whole thing around, and it's getting more and more difficult because the amplifier is now bloody heavy, and I mean really heavy. So it's reached the stage where I probably need to reinforce the frame, because I'm afraid it really cracks and parts fall off it. So a lot more metal has been collected on the weight gaining stage of the tube amplifier. And in case you didn't realize, I just really quickly describe what are the things which are new and some of the things which are already old. So here you still have got these ugly DC power supplies, these cheap little China power supplies which I use for the end tube, the power stage tube heating. And then I use the heating transformer as a choke to just really get some of the high frequency disturbances out. I've got some resistors to just really get the voltage level for the heating all okay. Some capacitor to filter out even more of the crap, which is then finally going to the filaments. But this is all old, so I already described this in the previous episode. But the new bits are these chokes now, and I ordered them about 2 months ago, and it took more than a month for them to get delivered. You certainly are aware that there's always quite some money to spend when you send heavy goods from China over back to Europe in this case. So I ordered a couple of chokes. I've got a few more directly in the same batch, and also here there's a smaller one and another smaller one, which are all 10 Henry. So the big ones are 10 Henry, they are rated 250 milliamps, and the small ones are also 10 Henry and they are rated 50 milliamps. And what I have done is to filter the power a bit better by using these chokes. How I've done it is that I used the big 3 Henry chokes, which are on the other side of the amplifier, and put those one in series. Then there's some electrolytic capacitors after the first stage. Then there's another 10 Henry choke directly after the electrolytic capacitor, which then goes to one of those switching power supply capacitors with very, very low ERS value. I selected specific ones which are now packed in copper foil, so you don't see it anymore, but I explain a bit later how I came to this choice. And then this one is going into another 3 millihenry choke and to the power stage. But before the 3 millihenry choke, I just really have got kind of a a jumper out, which then supplies this choke and also this choke, which are separate power supplies, kind of, which already start from the filtered voltage of the general power supply and supply only the driver tubes. So all in all, I've got now for the drivers driver tubes something in the range of 30 Henry plus capacitors, and the capacitors are 130, 230, which are on the other side of the of this board here, mounted to the top surface. Then I've got a 40 microfarad power supply condensator. So these switching power supplies, low RS capacitors. And then these are going through a 3 Henry choke to directly supply the power end tubes capacitor. So the power tube capacitor is this one, the pre-stage or the driver tube is another one, which then gets supplied through the small little choke. So it sounds all a little bit confusing. In the end, it's pretty simple in the way that each tube has got its own power supply now. They are all tapping in the same common voltage, but it is like that. So I get very, very nice filtering. I didn't really check what the noise level in the supply voltage would be like, but it's now really, really completely overkill power supply with each tube more or less going at least through 20 Henries of inductance or inductivity, and something like 300 in total microfarad low ERS capacitors. Once you select those capacitors, what you'll find, and what I've done is, I just really went to the Mauser page. Then they've got a very, very, very good and helpful table, which also specifies the resistance of all of the capacitors, and you can just really order them top to bottom, and you can select also your operating voltage. And for the capacitors, I selected quite high voltages because I did not really want to have them specific for low voltage supplies, but really also to be able to use them for all kinds of tube amplifiers at the same time. And then it spits out the best of whatever is available on the market, and then you can look at what kind of capacity you're looking for. And if you're clever, then you will also notice there's a very, very specific behavior in the characteristics of these power supply, switching power supply capacitors. And this is that the higher the capacity, the lower the ERS, which seems kind of intuitive. So the bigger the capacitor that you have got, the lower is its resistance against voltage changes, but only up until roughly 40 microfarad. And from 40 microfarad, very, very roughly, plus minus a couple of digits, up and down, the ERS does not change anymore. So even if you go to 100 or 200 or 400 microfarad, the ERS stays more or less fixed. So the best bang for the buck you're getting if you do the choice of taking those 40 micro capacitors, and I've got some which I can just really dig out what I've collected. So here I just really try to keep it a bit further away from the camera. This is one of those capacitors. These are Panasonic ones which I selected. There are also different other kind of brands that you can get, and this one here which is also, I think I've got currently like 5 or 6 in the tube amplifier of these guys here. They have got, maybe you can read it, I don't know really, I just really need to look at the monitor of the camera, but this is a 40 micro 800 volt DC link capacitor. So these are the really, really good ones which are very, very good to be used in power supplies. And what I mentioned initially is I did not use them directly straight behind the diode or the rectifier tube, simply because the low ERS values don't help you in this regard, because they directly after the rectifier, the ripple is very, very high, which means with a very low ERS capacitor, you're introducing very high currents, and you just don't want to do that. At least I don't want to do that. So I would like to have something which is a little bit milder and just really start with these high quality capacitors after the first choke, when there are not anymore these very, very wild peaks. The low ERS helps you then to dampen all of the very, very small ripples and noise from the last bits which are remaining on your DC voltage. But all of this doesn't matter if it doesn't sound better. And what I noticed very, very, very clearly is that mainly the bass extent, and also the, how you say, the sound characteristics is much improved with the amplifier. There's also a little bit of an improved high resolution, I would say, in the upper frequency range, but that is relatively subtle. So the main difference I really notice in the low and in the lower mids. But definitely it's a really, really nice gain compared to how it sounded before, and especially because my network here at home is not really great. I think there's a lot of noise in the system, just from what I get supplied to my plug, and I definitely have to work very, very hard on the power supplies to get rid of all of this noise. And that is also one of the reasons why I didn't really post any more updates, because I really wanted to listen to the system the way it is right now. And about a week or 1.5 weeks ago, I got really, really confused, because it suddenly started to sound quite harsh. Not what I used to hear before. And something really has changed, and I checked everything of my system, if everything is plugged in correctly, none of the things which I could see were wrong, or anything that I could have changed on the setup. And I did not change anything on my system during that time. So I really suspect that as there is some construction work going on the house at the moment, with even an extra high current power dump from the house to one of the big cranes here where they are doing some construction work, I really think that this negatively affected my hi-fi system. So it calmed down a little bit, but it's still not really at the level it used to be. So I definitely need to do something on my power supply. And one of the alternatives that I had in mind was to once build a MOSFET amplifier similar to what I've done already once before, but this time exactly to build it like a tube amplifier. So to have only a driver and a power stage, and that would be pretty minimal, and to maybe even use an output transformer just in order to get the voltage down, to be able to do a battery supply for the amplifier and to be completely independent of any kind of external power source. And this is what I'm doing already on the phono stage, and I think this is working at least to my great large satisfaction. I even calculated it for tube amplifiers, but yeah, I think to me it's a little bit, I'm not really currently at the suicide age. I don't really want to have like lithium polymer 400, 500 volt batteries lying around to play with. If something goes wrong, then let's say I will blow up the complete flat and burn myself and kill myself and anybody else around me probably. So I stay away from this. Now, a lot of talking already about this, but these changes have been really positive. The time to switch on or from switch on of the power amplifier until I can hear some music is a little bit longer, but yeah, we are speaking about a couple of seconds, maybe 10 seconds, 15 seconds or so. Nothing really dramatic. The heat up of the tubes is still the dominant factor, and the capacitors are not really contributing a great deal by that. But now let's move on to the CD player, because I see already I talked far too long about the tube amplifier, and let's look at the CD players. So what's going on here? I just really move over to show you what I've got here, and this is a bit difficult because it's all black front, so I don't know if it helps to just really move the thing around a bit and get a little bit light also to the front face. I think the contrast is just really a bit too high for this to work properly, but what you could see if there would be a bit of light coming from the right angle, and maybe I can still turn it around a bit more. So now there's a bit of a shadow from my tube amp, but hopefully you can see now a little bit better what's going on here. So the main candidate right now that I'm looking at is the CD player right at the top, which is the Grundig Fine Arts 9000. And obviously I got it used because I think they're not in production anymore since 30 years. Then my previous CD player, which is an Onkyo 3755. Yeah, a little bit mixed about this one. And then I've got the good old Denon, which is here at the bottom, which is the 2560, which I got also for a reasonable price because the guy I bought it from mentioned something about some ticking noise, but to me it sounds perfectly fine. It's just really the CD drive when it skips from track to track that sometimes it's a little bit louder, sometimes it's quiet. So why did I buy these CD players? I think the Denon I really just bought because it got some really good rating and has got some interesting technology, but I won't really refer to it at this time. The main candidate right now, and the one which I'm currently also extremely happy with, is the Grundig Fine Arts. And the ones which are a bit into CD player modding probably know already. This one has got the TDA 1541 chip, the famous Philips chip built into it, with also the digital filter, the 7220. And just really the look at the top will already expose you what I'm talking about and what I think most people do with these kind of chipped CD players. First of all, it has got a really nice CD drive, so the transport is already a quite nice one. It's a suspended CD drive. You maybe don't really see it, or maybe if I tip on it, you can see that the whole thing is suspended and vibrates. Yeah, so it is sitting on a sub chassis. And the other speciality about this one is that it spits out the CDs when you open the sled at such a speed that the CDs are still rotating when they when say the drawer is opening, which is a really special one. Besides that, I haven't really done an awful lot except of course opening it and inspecting it. Also the housing is very nicely done and perfectly sealed. There was close to zero dust in the CD player, and I'm pretty sure it was never ever opened, simply because the screws look totally untouched. The only area where there was a little bit dust was of course along the drawer. When it opens and closes, there's of course always a little bit of dust coming in. And you can see already, and probably spotted it, the main part of the modification. And maybe the camera will be even, I don't know if it's possible even to get to focus it on a close distance. So I did a little bit of playing a spider here by connecting alternative capacitors in parallel to the ceramic capacitors. So the ones which are a bit into these TDA chip love probably know that you can tune the sound of the digital analog converters quite a bit by playing around with the capacitors. And in this particular example, it's probably not going to focus properly, but you can see that it's a 14-bit chip. So each chip has got a ceramic capacitor, unfortunately an SMD ceramic capacitor for the decoupling. And those ones I replaced by generous DC Link 1 microfarad capacitors. So they are 10 times bigger than the normal capacity. Doesn't necessarily mean that it's better, but of course they've got a much better quality. I also wrapped all of them in copper foil. It's not really connected yet, but nevertheless, and the single pins for the chip are connected with twisted, very thin copper wires to make the connection. And the CD player, when I got it, I gave it a quick listen at the very beginning, and I wasn't superly impressed, I have to say. In fact, I was a little bit disappointed and did not really find the sonic characteristics that usually were described and attached to the TDA chip, because I clearly heard the mid-range was very nice. Also the highs were quite nicely resolving, but it had quite some sharp higher mids, which I thought were not really what you normally would expect from the TDA chips. So after converting the converter, the digital analog converter, and adding those 14 capacitors, it completely transformed, and it was a change like a night to day. I think it jumped I don't know how many classes and categories up. It was incredible change, and now this is by far the best CD player I ever heard. And I haven't really touched the power supply nor the output stage. It's still also doing its oversampling and all of this other business, and I'm just really at the start of getting into the CD player modding. But this is currently the stage I am at the moment, and I will pursue this, and I'm super happy with the results that I got so far. And up until the last bit, if the battery will still give me some mercy and continue to work. And this is going to now the back sides of my petit, because what I've done was I switched out the drivers from being the 103, the Fostex FE123. Don't know if maybe I can turn those around. I tried a couple of things with those. Now you can see it's both of the speakers are on top of each other. So here we have got now the 126 drivers, so one number up from the 103. Don't like them. So the reason why I don't like them is they improve in areas where I don't need them to improve. But they lose in areas where I would like to retain the characteristics of the small little Fostexes. And the Fostex 103 in particular has got this very, very, very subtle, how you say, musical and very, very nuanced dynamics. And you can hear this in particular with all of the sounds which are happening in the background. So not all of the foreground instruments, but it's more the layering and what sonically happens in the backgrounds where these small little FE103s really shine. And they are some of the best speakers in this regard I ever heard. And they are definitely better than my small little emergency two-way speakers. But these ones here, they lose out on this, but for the expense of adding a little bit of mid and bottom end. And I'm not looking for this. I'm really looking more towards a more rounder sound, and I'm willing to sacrifice bass, especially because, yeah, you won't get the ultimate bass out of those speakers anyway. So what is my plan now is more or less what you can see already, or what you might have seen here with this speaker here. Maybe it also starts to focus. So my plan right now is to use the 103, this little guy here, and to use it as an open baffle medium high speaker, and to put some sub below. And it's not the setup which you will see here. This is just really a kind of a very first test, and I wanted to see how it performs in an open baffle, just really giving it some measurement to see how much of the mid-range I'm losing. I haven't done that yet, still to come, but will be coming in the next couple of days or so. And I would like to use the open baffle as a kind of a natural frequency crossover to bridge the Fostex speaker to the subwoofer, which then could be like these 12-inch drivers which are still left from my old open baffle. Basically, I cut my old open baffle into half, and previously here there was one of those Thiele ceramic mid and another tweeter also from Thiele mounted, but I don't have the other half here, and I just really wanted to mount it here. Another interesting alternative is the horn driver, which I've got here, and I showed this in one of the earlier episodes, and maybe it's also focusing at some point. And what I try to do here is to not really have it firing upwards, but to transform it to really like a dome tweeter. And this you can do by removing the back. Because then it's not really a compression driver anymore, but you've got a 100mm dome titanium tweeter. And now the opening towards the horn, which is normally back now with the fresh battery. So what I was trying to explain is to use a horn driver as a normal dome tweeter. So this time I've got the driver directly in my hand, and this is the backside of what would be normally a compression driver, and here you can still see the housing, the backside housing, which normally sits quite close to the diaphragm that you can see here right now. So one alternative to the FE123 was, or would be, to use just this horn driver as a dome tweeter and to also mount it in an open baffle. And in this case then I need to be really careful to not really damage this thing, because now this is a, you directly look at the titanium diaphragm and this orangey surround. I think it's just really the Kapton film which connects to the coil, which moves the diaphragm. So it's 100mm diameter, quite a big thing. And normally what you would see, and I just really have to now change hands a little bit to give you a chance, but without destroying the whole thing. Normally this is what you see. So this would be the front end of the dome tweeter, and the back end is of course closed to the back, and you won't even see it. But my idea is then to have got the small diameter, which is a 2-inch opening here for this particular version, facing towards the back, and to have the 100mm diaphragm directly facing to the front and emitting all of the sound, which means that it has got even a larger active surface than the 103 Fostex driver. I have done some measurements already with this one, so you can see that I have fixed the diaphragm with some alternative screws, and it's pretty rigid on this driver, so you can see it without the need of having the circumferential clamping from the compression driver's original housing. So I think that works pretty well. It's not ideal, and I would probably machine an aluminium ring to really push all of the circumference of the suspension down to the magnet to get the best results. But this would be also a way of building your two-way speaker with this one more or less completely emitting almost a complete frequency spectrum, exactly like it would be for the Fostex 103 in the petit speaker, but then to add a sub. And for the sub, or for the low frequency, I would like to have something which really has got the maximum, how you say, the maximum transmitted frequency from that lower driver in the 200-300 range, at least to have the crossover in this range, and then it would be going down probably with something, I guess I need 24 dBs, because usually these big diameter drivers, they increase still in sound pressure level at this frequency, even naturally. So you need to combat the natural increase in the frequency response and still then quiet it down. And I will opt for something which is again quite wide, going with a low bass speaker, which runs clean at least up until 1 kHz, preferably even higher, but normally they fall apart above 1 kHz, so 1 kHz is already a good target. It would be like 2 octaves higher than the planned crossover frequency, so that in the overlap there's nothing odd going on. And this is the most, in my eyes, the most important frequency spectrum. It's just really where all of the male and female voices would normally be situated. Of course, not the upper frequencies of the sound of a voice, but at least all of the bass frequency, even up until quite high tunes. So this might be some future plans, so I might try doing this compared to what I initially mentioned as an omnidirectional speaker, which still would be my ideal, but at least it's getting relatively close, because you all know, of course, that the low frequencies radiate in all directions anyway, so you don't need to take care about those ones. But especially the ones which are then going higher, you're getting more and more of a coil effect. And I would like to really avoid this and to have something omnidirectional with reflections from all over in my room. So that's it for today. I'll keep posting some updates from time to time whenever I've got some substantial gains worth mentioning about. Also for my own records, like I mentioned already earlier, so this is not really to promote any products, to get some sponsors or whatever, and just really see this as a kind of a podcast with some pictures of shaky images that make you sick. But at least I hope that there's a little bit of technical information and some explanations of my train of thoughts when undergoing my explorations in HiFi.